Good afternoon, everyone, and we are into the third lecture on Newton laws. And in this, we will be dealing problems with equilibrium, and I hope that we can cover this. In the last class, we had discussed some problems based on the free body diagrams, and I told you that these free body diagrams are very important. Once you get these free body diagrams and draw them correctly, the rest of the question becomes very simple. Yes or no? Well, I will just give you one or two more free body diagrams if you can draw them. So I'll just continue on this. If I have a system like this, let us say this is M1 and let us say this is M2. Can you draw the free body diagram of this system of the blocks M1 and M2? Can you draw the free body diagram of this block M1 and M2? Yes. Remember, we only need to draw those forces that we see. We don't draw those forces that we don't see. And we draw them correctly. If the force is pointing upwards, we must point it upwards. The force is pointing downwards or leftward or rightwards, we should draw it accordingly and not because of our whims and fantasies. Once you understand this free body diagram, the rest of the question should be pretty simple. Has everyone drawn the free body diagram? Okay, so how does the free body diagram look like? Oops, wrong color. Let me start with M1. So the weight of the block M1G goes down. There is a string. The tension in the string is T. This is the free body diagram of M1. To draw the free body diagram of M2, I draw the weight M2G. But I understand that this is kept on a surface. So this surface would be giving it normal reaction. Let me call this as N2. It is attached to a spring, to a string. Spring is giving it the tension T. So this is the free body diagram of block M2. Do we understand this? Yes or no? Now, sometimes they might also ask you the free body diagram of the pulley. So as you can see, this small thing, T and T, this is the free body diagram of the pulley. Do we understand this? Yes or no? So these are simple things. I'll give you one more. Everyone got this diagram? Yes or no? I'll try to give you one more. And I hope we can draw the free body diagram. Now remember, when there are more than one strings, you must name the strings or you must draw the tensions carefully. For example, if this is the system, this is block M1, and this is the block M2. Can you now draw the free body diagrams of M1 and M2? Let me just make this string a bit longer. In this case, can you draw the free body diagrams of M1 and M2? I'll give you one more. Once you are done, then I will discuss them all. This is M1. This is M2. And this is M3. I'll give you one more. Remember, all these are questions. They are not diagrams actually. They are a part of questions, and these questions we would be doing in the time that is coming. So these are basically questions. They are not diagrams. They are questions. But if you understand them, the only difficult part of solving this question is to draw the free body diagram. So if you get the free body diagrams correctly, you should be able to solve these questions whenever these questions come. So I'll give you 2 minutes to look at all these diagrams and draw your free body diagrams. I hope you are able to draw the free body diagrams. Let me go ahead and draw from my end. Let me start with the first diagram. Let me call this tension as T1 and let me call this weight as M1G. This becomes the free body diagram of M1. Now let me write the tension everywhere. Tension on the pulley will be downwards, T1, T1. This would be the same pulley, so tension remains same, T1. So I've drawn the tension T1 in the pulley everywhere. You see this, yes or no? Then I have this string. So the tension should be different. You can call it T2, you can call it T3, T4, whatever, but don't call it T1 because it cannot be same as T1. So this becomes the free body diagram of this pink one becomes the free body diagram of M2. Do we understand this? This green one becomes the free body diagram of M1. Do we understand this? This blue one becomes the free body diagram of this pulley. Now, remember from this, I've drawn the free body diagram of the pulley. Now remember this pulley, the blue pulley that I'm drawn, this blue pulley is actually an ideal pulley. It does not have any mass. It does not have any friction. Since it does not have any mass, the net force acting on it, because the mass is zero, even though it is accelerating, the mass is zero, we will call that will remain in equilibrium. So whatever be the force in the upward direction, same will be the force in the downward direction. We will see when it comes. Just remember that. Okay, let me also draw the free body diagram of this pulley. Now T1 and T2, T1 and T are here. There is one more string. So let me call this tension as T3. So this brown thing becomes the free body diagram of this pulley. Do we understand this? Remember, I have named different strings by different tensions. Not necessary that you will call tension T1 in this string. You can call tension T1 in some other string. But remember, 3 strings should have different tensions. Do we understand this? Let me move on to this second diagram. This is M1G. I'll call this as tension T1. This will be tension T1. This will be tension T1. This would be tension T2 because the string is different. This one will be tension T1. Remember, to draw the correct direction of T1. T1 always pulls. Whether it is pulley, it is pulling. Whether it is mass, it is pulling. It always pulls. Now, when I draw the free body diagram of M2, there is M2G, which is the weight of this block. Do we understand this? But there is also one pulley, one string here. So I will call that tension as T3. This string will have the same tension T3, and this block will have the weight M3G going downwards. So the free body diagram of this green block is given in this green block. We understand this? The free body diagram of this pink block is given in this pink area. I hope everyone has drawn it correctly. The free body diagram of this blue pulley is in the blue range. And the free body diagram of this block is this one. We understand this, everyone? Remember, you may call tensions by different names, but there are three different tensions that you can see. So these three different tensions should be there. Let me move on to the next one. This is block M2, so I'll call it M2G. Since the block is M2, so I will call this tension as T2, so that 2 and 2 look same. This tension will act on this pulley also, T2. Since this block is attached to this one, so I'll call it T1. The weight is M1G downwards, but this is also kept on a block, so N1 comes upwards. Tension T1 should remain same. So this is T1, 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 and this is T1. This is also T1. You may call T1 as T, you may call T2 as T1, doesn't matter, they must be different. This pink is the free body diagram of this pink block. We understand this? This green thing is the free body diagram of this green block. I hope things are clear. Yes or no? This yellow pulley. This yellow thing is the free body diagram of yellow pulley. No one will ask you the diagram of pulley, but we'll use it somewhere. This blue pulley. This blue thing is the diagram of this blue pulley. T1 here and T2, T1 here. Then we have this pulley as well. So this is the diagram of this pulley. I hope we understand this, everyone. So this is all about free body diagrams. By free body diagrams, what we mean, we just see the block and we draw their diagrams. I'll give you one more just to be sure. So one more. I just want to make the block on an incline, and that is the only reason I'm giving you this. So this is M1. This is an incline at an angle theta. And this is M2. I'll give you a minute to draw the free body diagram of this one. You can see a pulley as well. And you draw the free body diagram of this block. I'll give you 1 minute. I hope everyone has drawn the diagram. Let's see. How I draw the diagram? Again, the weight of the block M1G. There's only one tension, so why should I call it T1? Let me call this as T. The same tension will apply here, same tension will apply here, same tension will apply here. The weight of this block goes downwards, remember that? And this block is kept on an incline on a surface, so this N2 comes here. This is my pink block, and the pink thing is the free body diagram of this pink block. I hope you understand this. Yes or no? This is the green block, and it has a very simple free body diagram. One force upwards, one force downwards, that's it. If asked, this is the pulley, the blue pulley, and this is the free body diagram of the pulley. I've not drawn the force by the hinge on the pulley anyways. Do we understand this? Yes or no? Okay, having said that, let us go back and see what was Newton's first law of motion. What was Newton's first law of motion? Newton's first law of motion was very simple, and it states that if a body is at rest, it will remain at rest. If the body is in motion, it will continue its motion unless an external force acts on it. That means Newton's first law talks about a very special case. Newton's first law talks about a very special case, and if I may go back to Newton's first law, Newton's first law talks about a very specific case. And what is the case that Newton's first law talks about? The net force acting on the body is zero. Yes or no? If the net force acting on the body is zero, Newton's first law states that body, if at rest, remains at rest. If in motion, it continues its uniform motion. When I say it continues its uniform motion, that means the velocity remains constant. Now, it talks about a very specific case where the net force acting on a body is zero. Wherever the net force acting on a body is zero, wherever the net force acting on a body is zero, we call such bodies as bodies in equilibrium. We say such bodies are in equilibrium. So by equilibrium, what we mean is either the body is at, by equilibrium, what do we mean? We mean that either the body is at rest or the body is moving with uniform velocity. In physics, if we talk about physics, a body at rest and a body moving with uniform velocity, in physics, there is no difference between this. Physics says that if you are at rest or you are moving at uniform velocity, the laws of physics are actually exactly the same, which is applicable on you. Net means body is in equilibrium. So it can be at rest, it can be moving with uniform velocity. Do we understand this? Yes or no? Now, as we go further in our class, and we'll understand that we call whatever motion we are studying now, we call it translational motion. Did I tell you that, or yes or no? That this motion is known as translational motion. So we'll study in the chapter which is coming up that when the net force on the body is zero, instead of calling it equilibrium, it is better or correct to call it translational equilibrium. The body is in translational equilibrium. That is the right word to use. Not equilibrium, but the body is in translational equilibrium. Now, if the body is at rest or the body is in uniform velocity, the motion is same as far as physics goes. We call that motion to be a motion of equilibrium, or the body is in equilibrium. Now, whenever we get questions on equilibrium, and you might get a couple of questions on equilibrium, you have to remember what are the steps that you need to follow to solve those questions on equilibrium. So I'll give you that step by step, and instead of me writing, I will just, since I'm going to say the same thing, I will just show it on a thing. How do you solve problems when bodies are in equilibrium? The first step is always to draw a sketch of the diagram. Simple as sketch. You don't have to draw this sketch because this sketch is already there in the question. Probably the question will have that sketch. So this first, you may not draw it, but the second one is more important. The second one is the most important one. Isolate a single body and draw the free body diagram. You must label all the forces acting on it. So the most important step is actually step number 2, because step number 1 is already there in form of the question. You have to isolate the body and draw the free body diagram. Step number 3 would be to choose a convenient coordinate system, X and Y, and resolve all the forces along X and Y. There could be some forces which are not there along X and Y, so you have to choose your X and Y directions accordingly. How are you going to choose your X and Y directions? We will see it by examples, don't worry. So you have to choose a convenient coordinate system of X and Y, resolve your forces along X and Y. Then you must know that the body is in equilibrium, or the better word is translational equilibrium. So the net force should be 0. When I say net force is 0, that means net force along x-axis would be 0 and net force along y-axis be 0. That means that if there is a force on the left hand side, there would be an equal and opposite force on the right hand side. So right hand side force will cancel the left hand side force. Upward force will be equal to downward force, so they will cancel. So all the forces will cancel out each other, and we will say that the body is in equilibrium. Do we understand this? So these are the steps that you must follow to solve a problem for translational equilibrium. With these equations, you will get some equations. Once you get those equations, solve those equations, and you solve the problem. Have you written down these steps, everyone? Just write in very short. Again, you don't have to write it in English. Just have to write it in the language that you understand. Could be any language. Just have to understand what you have to do. Once you tell me that you are done with this, then I can move and you can solve some problem and see how we are going to apply those steps in various problems. So let me know once you have noted down. And once you solve 2 or 3 problems, you will remember all those steps, because all those steps are going to come automatically. You don't have to remember, oh, okay, I've done this, now what to do. You will understand, okay, this has been done, now this has to be done. This has been done, now this has to be done. Have you noted it down, everyone? Now let us solve some very simple problems based on this equilibrium. For example, we have got a body of mass m attached to a string. And someone asked me, obviously the body is not moving, the body is in equilibrium. The body is at rest, body is in equilibrium. What is the tension in the string? Someone asks you, what is the tension in the string? How are we going to find it out?
Excuse me, sir.
Yes, beta.
Sir, please show the previous slide one again.
Okay. Not written it. Write it down. Let me know once you are done. Okay. Shall we move ahead? Okay. Now let us see how are we going to apply those steps on this problem. So the first
Upward
step,
force is equals to downward force.
the first step is draw the sketch. There is no need to draw the sketch because sketch is already there. The second thing is isolate the body. There is only one body what to isolate. The second step is isolate the body and draw the free body diagram. So let us start with the free body diagram. Mg will be downwards and T would be upwards. We have already drawn that free body diagram. The third step is choose convenient axis as your x and y. When the body is hanging vertically like this, which axis you should choose? This will be your y axis and this will be your x axis. Yes or no? This is the most convenient axis. I will not draw it every time. I'm just showing it what we have to done. Now we have to equate all the forces are along the axis. There is no force going like this or that. I just have to equate forces. As you can see on the x-axis, this side or this side, there is no force. So there is no point of writing any equation. On the y-axis, you see upwards we have one force and downward we have one force. They must be equal to each other, yes or no? So from there we will get the equation and the equation is very simple. This T will be equal to mg and you get the value of tension from this. Do you understand this? How simple it is? Okay. Now let us see if we can do the next problem based on this. As you can see, all the steps here are, what should I say? Oops. All the steps here are automatic. They are coming automatically. Let me switch on my Wi-Fi. Can you see this better? Can you see my screen? Okay, I will keep my camera off because the light has gone. Okay, now I can switch on the camera, not a problem. Okay, I'll keep the camera like this. Okay, I'll keep it switched off. So now, as I said, all the steps are automatic and you don't have to think much about those steps. Let me give you a question and see if you can solve this question with what we have discussed up till now. So, as you can see, this is the question. You can see this block attached to two strings. One string is OA, the other string is OB. Can you find out the tension in the two strings? Can you find out the tension in the two strings? I'll give you 1 minute to do this. Let me know, bacha, if you are done. Hmm. You can call if you want, just to be sure. Tension in this string as T1 and tension in this string as T2 if you want.
So T1 is 10 Newton.
T1 is 10 Newton. That looks good. What about T2?
T2 20, sir.
T2 is 20, sir. That is absolutely right, sir. Well done, sir. What about the others, sir? Everyone got the same answer, sir?
Yes, sir.
Or shall I do it for you how it is done? Okay. How it is done? I will do them step by step. Let me take everything out. See, all the steps are going to come automatically. The first step is, let me name this question number 2. The first step is draw a sketch. Sketch is there. Step number 2, isolate the body, only one body, what to isolate. Step number 3, draw the free body diagram. So I'll draw. The weight is given as 10 root 3. So 10 root 3 is downwards. Now, there is one tension T1 in this side. Do we understand this? It is going to pull it here. There is one tension T2, which is this side. Done. Free body diagram done. What next? Well, the next thing it says is choose convenient axis. Which axis should I choose here? So I will choose this as my y-axis and I will choose this as my x-axis. Do we understand this, everyone?
Yes,
Y
sir.
and X are chosen. Now, what do I see here, bacha, is this 10 root 3 and T1 are okay. They are lying along y-axis and x-axis, but this T2, this green one T2 is not lying along x and y. So what I need to do with this T2, I need to resolve this T2 along y and x axis. So how will I do this? Anyone? How will I resolve this T2 along y and x? So I will write it like this. This one will become T2 cos 60. Yes or no, bacha? How did I get this?
Yes, sir.
I will tell you how did I get this. Let me take this T2 off. This angle is 60. So this angle is also 60. So this is the axis with the angle. So it is T2 cos 60. And the upper one is T2 sin 60. Everyone understands this? Yes or no? Then the only thing is you need to equate the forces along x and y. You see y-axis upwards, y-axis downwards. What is the force along the upward direction? You can see it is T2 sin 60 and you can see the downward force is 10 root 3. So the first equation I can get, the green equation, is T2 sin 60 is root 3 by 2, bacha, is equal to 10 root 3. Everyone got this equation? Yes or no?
Yes, sir.
Root 3 goes away and I will get the value of T2 as 20 newtons. Then let us look at this yellow equation. On the right hand side, I have T2 cos 60. On the left hand side, I have T1. So what is the blue equation? T1 is T2 cos 60. We already know the value of T2. T2 is 20. Cos of 60 is half. So this becomes 10 newtons. So the value of T1 is 10 newtons and the value of T2 is 20 newtons. Everyone understands this? Yes or no? Can I have raise hand from everyone? Everyone got this also? Great. I'll give you 1 minute to note it down. And then we'll move on to the next question fast. Everyone noted this down?
No, sir.
Okay, I'll give you time, don't worry.
Done, sir.
Answer. Then this question, sir, this system is in equilibrium. This system is in equilibrium. You have to find out the value of M1 by M2. I'll give you 2 minutes to do this.
Sir, 1.
1. Think again.
Yes, sir.
Don't think it's 1. Try again. Everyone getting 1? Shall I do it? Okay. The first step is draw a sketch. Sketch is there. Second step is isolate the body. Bodies are very isolated. Third step is draw the free body diagram. So let me draw the free body diagram. M1G. Let me call this tension as T1. This is 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 T1. But the other block is attached to a different string. So I must call it T2. T2. And this is M2G. So far, so good? Yes or no? Then let me take the pink block. And this is the free body diagram of the pink block. Yes. There is no force along x-axis, so I don't have to make the equation along x-axis. I only need to make the equation along y-axis. What is the equation along y-axis? Remember, this block is in equilibrium. The system is in equilibrium. What is the equation for this block? Tell me fatafat. T2, the upward force must be equal to M2G. Yes or no? Now let us move on to this green block. And you can see this green thing is the free body diagram of this green block. Again, remember this block is in equilibrium. There is no force along x-axis. What is the force along y-axis? Must equate. What is the equation for this block? Tell me fatafat. T1 is equal to M1G. Everyone understands this? Up till so far so good? Yes or no?
Yes, sir.
The only problem is T1 is related to, M1 is related to T1 and M2 is related to T2, and we still don't know what is the relation between T1 and T2. If somehow we can find out the relation between T1 and T2, this problem is solved. Yes or no? Now, how do I get the relation between T1 and T2? So you see it once and you will remember it always. Look at this blue. Look at this blue pulley. Now remember, in this case, the system was in equilibrium. In any case, even if the system is in equilibrium or not, pulley are always massless. If the pulley is always massless, force is equal to mass into acceleration. Mass is zero. That means the net force on the pulley is zero. Do you understand this? Net force on the pulley is zero always. So you see it once and you remember it. So the upper wala force on the pulley should be equal to downward force. The upward force is 2 times T1. The downward force is T2. Yes or no? Yes or no? So we get the relation between T1 and T2. Now combine everything and you will get the relation. M1 by M2 is nothing but T1 by T2. And T1 by T2 is half. So that is your answer that you are looking at. Do we understand this? Yes or no? No or yes? Similarly, if someone asks you, what is the value of T3? What is the value of T3? Look at the yellow pulley. Look at the yellow equation. Can you tell me what is the value of T3? Whatever happens, pulley is massless. Remember that. What is the value of T3? I can write T3 as
2T1 is equal to T3.
that is correct. T3 will be equal to 2 times of T1. Do we understand this, everyone? Yes or no? No, yes. Huh? Okay, I'll give you one more. Fast. Do it fast. You can do it fast. I can give one more probably after this, and we are done with this. So this one, and you draw it with me, and you will understand that we had already drawn this diagram once. In that case, we had only drawn the free body diagram. Now we have converted that free body diagram into a question. Remember, all those free body diagrams were basically questions. Oops, let me make it bigger so that I can draw the free body diagram. Oops, I can draw the free body diagram here on. Again, this is M2. Again, this is M1. I hope you have seen this diagram. Again, this entire system is in equilibrium, my dear friends. Can you now tell me the ratio of M1 by M2? This entire system is in equilibrium, dear. Can you tell me, bacha? What is the free body, I mean, what is the ratio of M1 and M2? First. Yes, bacha. Shall I do it for you? Shall I wait? Huh? Shall I do it? Okay. No one got the answer? The first step is draw a free body diagram. Draw a sketch. Sketch is there. Isolate the bodies. Bodies isolated. Draw a free body diagram. So M1G, normal reaction N1. Let me call the tension in this pulley as T. So this will be T. 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 T and T. Do we understand this? Yes or no? Now, going on to the next string, T and T are upwards. So straight away we can say how much will be the tension in the downward string. T and T are upwards and you have got a pulley. What will be the tension in the pulley? Downward. It will be 2T. Yes or no? We've seen it in the previous thing. So why will I T1, T2 when I can write in terms of T and 2T? Do we understand this? Yes or no? 2T. This is 2T. And this is M2G. Let me have a look at the blue block. Blue block. This blue block is in equilibrium. So what is the equation for this blue block? Only along y-axis the equation can be written. What is the equation? 2T will be equal to M2G. Do we understand this? Then we come to the pink block. And this is the free body diagram of the pink block. But on pink block, we must have equation along y-axis. Y-axis we have N1. And we have downward force at M1G. So we can write the y equation. N1 is equal to M1G. Yes or no? We got up till here. Now the problem is, and you should have told me, sir, there is a problem here. There is tension T. This tension T, but there is nothing here. So this block cannot remain in equilibrium. So I must have drawn a force in the backward direction. I must have drawn a force in the backward direction. And let me say, I have drawn this force in the backward direction. And this force must be equal to this tension T. Then only this block will remain in equilibrium. Do we understand this? Got this? Okay. So in this condition, it will not be possible for me to find the ratio of M1 and M1 and M2 because one block is on the horizontal surface and the next block is hanging. Do we understand this? I can only find M1 in terms of N1 and I can find M2 in terms of T. Do we understand this? Yes or no? Okay. So remember, whenever you are supposed to find out the condition of equilibrium, what you got to do is to write the equations along x and y axis after drawing the free body diagrams. Everyone understands this? Yes or no? Okay. One or two questions are left, which we will do in the next class tomorrow. We will wind up your equilibrium and move on to the next thing, which is Newton's second law of motion. So that will come in the next class. Take care. Have a nice day. Do you understand how to do problems on equilibrium?
Yes, sir.
I have sent you the sheet. There would be questions on equilibrium on the sheet. Please try them. I'll see you tomorrow. Take care. Have a nice day. God bless you all.
Thank you, sir. Have a nice day, sir.